Hi, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about the dimethyl terephtalate, or we call it as DMT, and terephthalic acid or TPA, synthesis and applications. So let's see the outline of this topic. So first we will go through about the background and history, then the reactions of DMT and TPA. After that we will go through the equipments and also the production process. Then we will go to applications of DMT and TPA, and the last one is the example of companies. So let's start.
Assalamualaikum. My name is Nur Syahira binti Muhammad Nazir. In this video, I will explain about the background of terephthalic acid and dimethyl terephthalates, and also the example of companies. First of all, terephthalic acid and dimethyl terephthalates are consumed primarily to produce polyester resins, fibers, and films. These are the example of terephthalic acid and dimethyl terephthalates. Both terephthalic acid and dimethyl terephthalates are monomer for the production of polyethylene terephthalates by polycondensation with ethylene glycol. In the production of the polymer, the acid has obvious advantage over the ester because the heat per kilogram of starting material is higher and no methanol recovery step is needed. In most applications, and especially in the field of fibers, monomer purity is an essential factor in polymer quality. Monomer for polyester production are among the purest high-volume chemicals.
Assalamualaikum. My name is Aini Sofia binti Abdul Halim, and I will present about the reaction for the dimethyl terephthalate and terephthalic acid. First of all, both terephthalic acid and dimethyl terephthalate are the monomers for the production of polyethylene terephthalate by polycondensation with ethylene glycol. As we can see here, both terephthalic acid and dimethyl terephthalate will react with ethylene glycol and produce polyethylene terephthalate. Next, I will explain about dimethyl terephthalate and terephthalic acid production. In the production of the polymer, the acid is more favorable over the ester because the yield per kilogram of starting material is higher and no methanol recovery step is needed. Monomers for polyester production are among the purest high-volume chemicals. Ester was not preferred because the latter is difficult to purify, it is not volatile, and does not readily dissolve in normal solvents. Oxidation of p-xylene with air will produce p-toluic acid. Further oxidation to terephthalic acid is very slow due to the high stability of p-toluic acid. The earliest process for TPA production based on p-xylene involve oxidation by nitric acid, which is a very strong oxidant. The oxidation of p-xylene takes place by a radical mechanism with cobalt acetate or cobalt naphthenate as the catalyst. There are two methods of conversion to proceed the production of terephthalic acid, which is the esterification of p-toluic acid and addition of extremely reactive radicals such as bromine atoms. The first method is to esterify p-toluic acid with methanol to p-methyl toluate, which is readily oxidized. Esterification proceeds in the liquid phase without a catalyst. In this process, p-xylene is converted in 4 alternate oxidation and esterification steps. As we can see here, polyxylene will react with oxygen to produce p-toluic acid, and p-toluic acid will react with methanol. P-toluic acid will react with methanol to produce p-methyl toluate, and p-methyl toluate will react with oxygen to produce methyl terephthalate. And lastly, methyl terephthalate will react with methanol to produce dimethyl terephthalate. The second method is the addition of extremely reactive radicals such as bromine atoms. These are formed by reaction of sodium bromide with acetic acid and oxygen. The bromine radicals then attack p-toluic acid. Once the p-toluic acid radical has been formed, the reactions can proceed similarly to the oxidation of p-xylene, finally resulting in the formation of terephthalic acid. That's all from me. Thank you.
Okay, hi and Assalamualaikum. So I'm gonna continue with the equipment slide. So firstly, the equipment for the written process is the oxidation reactor, acidification reactor, DMT distillation, methanol distillation, and flash vessel. As for the Amoco process, we have oxidation reactor, surge vessel, filter, dryer, acetic acid distillation, and scrubber. So let's continue with the production of process. So here we have the diagram of written process. The recycled p-xylene, recycled p-methyltoluate, and the catalyst are fed to the oxidation reactor, in which mixing takes place by the upwards movement of air. The p-xylene and p-methyltoluate are oxidized in the oxidation reactor. The temperature in the reactor is controlled by evaporation and condensation of the formed water. As you can see in the oxidation reactor, there is a coil there, so it will occur heating, evaporation and condensation process. So the product of the oxidation reactor is heated and fed to the acidification reactor, into which excess evaporated methanol is purged. So here, the p-toluic acid and methyl terephtalate are transformed to their corresponding ester non-catalytically. At the acidification reactor of the overhead, vapors are condensed, after which methanol is separated from the water and recycled. The liquid product from the acidification reactor is flashed to remove any remaining methanol and water. The acidification products are sent to a distillation column. In the TMD distillation column, p-xylene and p-methyltoluate are collected overhead and returned to the oxidation reactor. The crude TMD, after the removal of heavy byproduct and catalyst metal, is purified by decrystallization. So next we have the Amoco process, which produces the polymer grade TPA directly by the oxidation of p-xylene. In this diagram, p-xylene, acetic acid, and catalyst are fed into the oxidation reactor. The reaction medium is agitated by introducing air at the bottom of this oxidation reactor. The reaction takes place with acetic acid as the solvent for the catalyst. The air is added to maximize the p-xylene conversion. The heat generated and removed by vaporization of part of the solvent and by condensation and reflux to the reactor, which we can see that the oxidation reactor in the diagram, there is a coil, so there will be heating process in this, there will be heating reaction in this column. The generate steam can be used in the distillation part of the plant. So the next one is we have the scrubber. So the scrubber recovers the acetic acid from the off gases, which contains nitrogen, unused oxygen, and carbon dioxide, which resulting from oxidization. Because of its limited solubility in acetic acid, most of the PTA are crystallized while it's being formed. So a slurry forms in which removed from the base of the reactor and sent to the surge vessel. which in this search vessel operates at lower pressure than the oxidation reactor, where more TPA crystallize. The suspension is filtered and the crude TPA is dried and sent to the purification. Due to the presence of acetic acid and bromide, highly corrosive process conditions exist. Therefore, the use of special materials such as Terephtalate C or titanium is necessary in the reactor and some other parts of the process. So the purity of the crude TPA is already over 99 weight percentage.
Okay, so hi, I'm Nur Fasila binti Ahmad Salihin. So today I will going to present about the applications of TMT and TPA. So let's see. So first, TPA and DMT are consumed primarily to produce linear, saturated polyester resins, fibers, and films by reaction with glycols. Consumption of TPA and DMT is for the production of intermediate polyethylene terephthalate, or we call it as PET polymer. PET is consumed primarily in the production of polyester fibers, polyester films, and solid-state water-grade resins. Polyester fibers ultimately account for the majority of TPA and DMT consumption. Another one-third of consumption goes into the manufacture of PET solid-state resin for bottles and other packaging applications. The manufacture of polyester film, PBT, and other minor products such as cyclohexane dimethanol (CHDM), terephthalic chloride, and polyester ethyl elastomer account for the remainder of TPA and DMT consumption. Next is example of company.
For the example of companies, the first company to commercialize the use of the fibers made from polyethylene terephthalates were Imperial Chemical Industries in the UK in 1949 and DuPont in the US in 1953. Imperial Chemical Industries was a British chemical company. This company made general chemicals, plastics, paints, pharmaceuticals, and specialty products, including food ingredients, specialty polymers, electronic materials, fragrance, and flavorings. DuPont is an American company and it would pursue a separation into three independent, publicly traded companies, which are an agriculture, a material science, and also a specialty products.